Welcome to Science for Sleepy. Tonight, you and I are going to do something curious. We are going to compress the entire history of the universe. Everything from the first blinding instant of the Big Bang to this very moment, where you are lying somewhere listening to me into a single calendar year. Imagine it as a cosmic diary, where January 1st at midnight is the very birth of the universe, and December 31st at 11:59 and 59 seconds is now. Everything that has ever happened, from the birth of stars to the fall of empires, fits neatly into this year-long story. Now here's the part that should make you pause. If you flip through this calendar quickly, you won't find humans until the very last day. Not even the morning of December 31st, not the afternoon, not even late in the evening. We show up at 11:52 at night, just 8 minutes before the universe's grand party ends. And everything you think of as history, every pyramid, every war, every invention, every story of kings, peasants, artists, and explorers, all of that, it is squeezed into the final 60 seconds before midnight. One breath. That is how late we arrived, and how enormous the universe had already become before we even appeared on the map. By the way, before we go further, can I ask you a small favor? Just scroll down to the comments and let me know, where are you watching this from, and what time is it for you right now? I love seeing those scattered dots of time zones across our tiny planet. It makes this story even more fascinating. And since you already exist in the last few seconds of this cosmic year, maybe subscribe to the channel too. Think of it this way. Subscribing is like reserving your seat for the fireworks that happen in the very last second. And remember, we upload a new video every day which, if the universe were compressed into a year, would be like getting a brand new cosmic event handed to you every 12 million years. Not a bad deal. Now let's take a step back. January 1st at midnight, the beginning, the Big Bang. Not really a bang in the sense of an explosion with fire and smoke, but the sudden expansion of everything from a single point smaller than a grain of sand. Space itself was born. Time itself was born. There was no before, because before didn't exist. In that first fraction of a second, the universe inflated faster than the speed of light, stretching smooth and flat like dough being rolled out. It is one of those dull but significant facts. This evenness is why you can sit comfortably on Earth without half the sky collapsing in chaos. Within the first few minutes of our cosmic January 1st, the universe was a hot sea of particles. Protons and neutrons collided, fused, and created the first elements, mostly hydrogen and helium, with tiny sprinkles of lithium. That was it, the raw ingredients, the flour and water for a recipe that would not be baked for billions of years. Imagine cooking a stew that takes almost the whole year to simmer before you even taste it. That was the universe. After 20 minutes, everything quieted down. The great furnace of element making shut off. For the next several 100,000 years, or in our calendar, most of January the universe was dark. Photons, those little packets of light, were constantly bumping into particles, unable to travel freely. Think of it as a fog so thick that light itself couldn't escape. If you could somehow stand there in those early days, though, of course you could not, it would feel like standing inside a blinding, endless mist. Around the 27th of January on our calendar, something changed. The universe cooled enough for electrons to cling to protons, forming neutral atoms. The fog lifted. Suddenly, light could travel. That first light, the so-called cosmic microwave background, is still humming faintly across the sky tonight, like an old whisper from the first month of the year. Every time scientists turn their radio telescopes upward, they are listening to the echo of January. And then, the quiet. The Dark Ages. Picture February as a long, silent stretch where the universe contained matter, but no stars. It was like having all the ingredients for a feast, but no oven, no stove, nothing to cook with. Gravity slowly gathered hydrogen and helium into clumps. For millions upon millions of years, these clumps grew heavier and hotter, until one of them finally ignited, the first stars. But here's a thought for you while you are lying there, drifting. How would you feel, knowing that in this grand cosmic year, Everything you know, every sound of laughter, every flicker of firelight, every note of music doesn't even exist until the very last night. We spend so much time wrapped up in our tiny stories, but in the cosmic calendar, 99.9% of the year passed before the first human ancestor ever took a step. Does that make you feel small or strangely special? And here is another detail to keep in mind. Those first stars that lit up in February lived fast and died violently. They exploded, scattering heavier elements like carbon, oxygen, and iron across space. Without their deaths, there would be no planets, no oceans, no bones, and no you listening right now. To make a human ear or a human heartbeat required whole generations of stars living and dying long before the Earth itself formed. The universe had already been bustling for months on this calendar before the stage was even set for us. So, when you glance at the clock tonight and see it tick past 11, remember, in cosmic time, humans barely just walked in. We are latecomers to a party that has lasted all year, and the decorations were already in place long before we arrived. What I find curious, and maybe you do too, is this. If so much has happened in the first 11 months and 29 days of the universe, what might still be waiting in the next cosmic year? If January 1st was the roaring birth of everything, then the rest of January is the cooling sigh. After those first violent minutes when particles smashed and fused, the universe slowed into something that almost seems boring, a long stretch of stillness and darkness. Yet it was this very quiet that made everything else possible. On the cosmic calendar, most of January is nothing you would recognize as scenery, no stars, no galaxies, no swirling colors in the night. It was emptiness, though not absolute emptiness. The fog was lifting, the particles were finding each other, and the cosmos was setting the stage. Let us imagine this together. You are standing in the middle of late January. You would see nothing, not because your eyes are closed, but because the fog has just cleared, and the photons are rushing out in every direction. This was the moment when the universe became transparent. Before this, light was trapped, bouncing endlessly between particles like someone stuck in a hall of mirrors. But around January 27th, the electrons finally settled into orbits, and the fog dissipated. Suddenly, light was free to travel. If you were there, you might feel it more than see it, like a sudden spaciousness, as if the air around you had shifted. That light never stopped traveling. It is still on the move tonight, 13.8 billion years later. When scientists point their radio telescopes at the sky, they are picking up that faint afterglow from the last week of January. They call it the cosmic microwave background, or the CMB, but you might think of it as the baby picture of the universe. Imagine carrying an old grainy photograph of yourself as an infant. That is what astronomers do with the CMB. Every slight patch of brightness and darkness in that ancient light became the seeds of galaxies, of stars, of us. And then came the long pause. February on the cosmic calendar is often called the Dark Ages, not because anything evil was happening, but simply because there was no light-producing object in existence. The photons were traveling, yes, but there were no stars to shine. Imagine a giant theater before the play begins. The chairs are set, the stage is built, but the curtains are closed and the actors have not arrived. That was February. Gravity, however, was busy. Hydrogen and helium gas, scattered thinly across space, began to feel each other's pull. Slowly, almost imperceptibly, they gathered into clouds. These clouds grew denser, their centers hotter, until at last, somewhere in the middle of February, the first star was born. It was not a gentle flicker, but a fierce ignition. Hydrogen atoms slammed together, forming helium, and in the process released energy, light, and heat. The cosmos was no longer dark. Those first stars were nothing like the sun, you know. They were enormous, hundreds of times larger, and they lived reckless lives. The bigger a star, the faster it burns through its fuel. Imagine a candle so huge it devours itself in seconds. Within only a few million years, which on our calendar is barely a day, these massive stars collapsed and exploded as supernovae. Their deaths scattered the first heavy elements into space: carbon, oxygen, nitrogen, and iron. If January gave us the basic alphabet of hydrogen and helium, then February started composing words. These were the syllables of chemistry that would, much later, form water, rocks, plants, and bones. Now, you might be wondering, why should you care about stars that burned out billions of years before Earth was even formed? The reason is unsettling in its simplicity. Without them, you would not exist. Every atom of calcium in your teeth, every drop of iron in your blood, was once forged inside a dying star. When you hear the phrase, "We are stardust," it is not poetry, it is chemistry. It is a literal statement. You are, quite literally, the ashes of those first February stars, walking and breathing. As February progressed, these stars gathered into clumps we now call galaxies. The Milky Way, our own home galaxy, was among them, though at this point it was only a hazy blob, a faint whirlpool of light in a vast black sea. Galaxies formed like islands rising from an ocean, each one filled with billions of stars. Imagine February as a time when the theatre lights were switched on, and suddenly the stage curtains parted to reveal not one actor, but countless performers, all stepping forward at once. But of course, the play was still young. Galaxies collided and merged. They danced across the cosmos, tugging and pulling at one another with their gravity. Even now, billions of years later, this dance continues. Our Milky Way is slowly moving toward its neighbor, the Andromeda Galaxy, and in a few billion years they will collide, blending their stars into one massive system. On our calendar, that event would fall somewhere in a future January we will never reach. While you are lying there listening, perhaps half asleep, think of this. The first stars that lit up in February are no longer there. They burned too quickly, vanished too soon. Yet their ghosts linger everywhere in the iron railings of bridges, in the oxygen you inhale, in the carbon that makes up your very cells. Your body is a graveyard of stars, a museum of February's first experiments. You carry their legacy without ever noticing it. This is one of those dull details that becomes quietly extraordinary. The universe spent the first 2 months preparing ingredients. Only hydrogen, helium, and a little lithium came from the Big Bang. Everything else, all the colorful variety of the periodic table, was forged inside stars that lived and died before Earth was even an idea. February was the month of manufacturing. It was the month when the universe stocked its shelves, waiting for some later day when planets and life would find use for them. What strikes me as curious is how patient the cosmos was. Humans are impatient creatures. We wait a few minutes for a kettle to boil and tap our feet. But the universe? It allowed entire months to drift by in darkness. And then, once the first stars arrived, it waited billions of years for galaxies to form, stabilize, and nurture worlds. On the scale of this calendar, whole civilizations of stars came and went before Earth was even dust in the corner of a cloud. And maybe this is the thought I want to leave you with at the close of February. When you imagine yourself small against the scale of the universe, remember also that you are ancient. You are built from atoms older than the sun, carrying the memory of February's explosions. Your body, quiet and still as you drift into sleep, is a continuation of stars that burned long before there were eyes to see them. So, here is the question. If February was about stars making the raw materials for life, what did March bring? What happens when these galaxies settle, and one of them begins to swirl itself into the shape of a home we would one day call the Milky Way? If February was the month when the first stars lit up like sparks in a dark field, then March and April are when those sparks gathered into bonfires. Galaxies, those sprawling cities of stars, began to organize themselves. The universe, once a featureless expanse, started to resemble the structure we see in telescopes today. Vast filaments of galaxies woven into a cosmic web, with yawning voids of darkness between them. Picture it this way. If the universe were bread dough, February was when the yeast first bubbled, and March was when the dough began to rise, stretching and forming airy pockets. Except this bread was cosmic, and the rising pockets were galaxies spread across unimaginable distances. Galaxies did not float alone. Gravity tugged them into clusters, groups bound together in long threads. Imagine looking out over a frozen lake, where cracks spread like veins in the ice. That is how galaxies lined up across space, in an invisible lattice. Even today, when astronomers look at large surveys of the sky, they see this cosmic web, clusters like knots, filaments like strands of rope, and dark spaces in between where almost nothing exists. Now, in March, the Milky Way was only beginning to form. Our galaxy did not appear fully built, with spiral arms neatly tucked into place. It started as a small, irregular collection of stars, gas, and dark matter, slowly pulling itself together. Over the course of billions of years, it grew larger by devouring smaller galaxies, swallowing them whole like a predator. Even now, the Milky Way continues to feed, pulling in dwarf galaxies at its edges, slowly merging them into its spiral. Galaxies are not peaceful islands, they are more like kingdoms constantly at war, stealing territory and resources from neighbors. If you think of our place in the cosmos as a quiet corner, March and April remind you that it was anything but quiet. The Milky Way's early years were violent. Gas clouds slammed together, igniting bursts of new stars. Supernovae exploded, seeding the galaxy with heavy elements. Black holes at the centers of galaxies roared as they swallowed matter, spitting out jets of radiation. The universe in March was not a calm, starry sky, but a restless, fiery workshop. And here's a detail that is both dull and extraordinary. Even the shape of the Milky Way is a product of these long wars. It did not begin as a spiral. The swirling arms we recognize today only emerged after countless mergers and billions of years of reshaping. It is as though the galaxy wrote and rewrote itself over and over until it became what we now call home. April carried this process further. Across the universe, galaxies multiplied and matured. Some became elliptical blobs, some grew into massive spirals, and some remained irregular, like half-finished sketches. Gravity kept sculpting, pulling stars into new formations. And in the midst of it, in one small corner of one spiral galaxy, the ingredients for something remarkable were slowly assembling. Not yet planets, not yet life, but the clouds of gas that would one day collapse into a solar system. While you're lying there, perhaps drifting towards sleep, think about this. The Milky Way contains about 400 billion stars. Each of those stars could have planets. Some of those planets could have oceans, mountains, skies, and maybe even life. Yet for all of March and April, the galaxy was just building the scaffolding. The stage was enormous, but empty. It would take many more months before a planet like Earth appeared, with water trickling down rocks and tiny creatures swimming in seas. Galaxies, though, were not just passive backgrounds. They were engines. Every star they produced, every explosion they endured, was part of a cycle that enriched the gas within them. The first stars of February left behind elements that seeded the second generation of stars in March. Those stars, in turn, created more complex elements when they died. Over and over, the process repeated. By the end of April, the universe had become far more chemically rich than it had been at the end of January. The alphabet of elements was expanding, and without that slow accumulation, you would not have the ingredients for biology, for chemistry, for thought itself. Perhaps the most curious thought of all is this. Galaxies are not only the birthplaces of stars, but also of time as we experience it. Every second you count, every hour you pass, is measured by the ticking of atoms and the spinning of planets, and those exist only because galaxies formed and nurtured stars. Without galaxies, there would be no clocks, no calendars, and no way for you to mark December 31st at 11:59 as the moment you exist in. And yet, for all the immensity of March and April, you must remember how little of this belongs to us. The Milky Way is just one among 2 trillion galaxies in the observable universe. If you tried to write down their names one by one, you would run out of paper long before you finished. When you lie awake at night staring at the ceiling, you are part of a galaxy that is only average in size, orbiting an average star on an average planet. But that ordinariness is precisely what made it so stable, so capable of nurturing life later on. The extraordinary is built upon the foundation of the ordinary. So, here is a small, grounding image. Imagine yourself as a passenger sitting quietly on a train. The train is the Milky Way, carrying you along its spiral track, one orbit around the galactic center every 200 million years. You will never see the whole track, you will never get off the train, but you are on it nonetheless, sharing the ride with hundreds of billions of fellow passengers. And the journey began, for this galaxy, in those long months of March and April. And maybe the question that lingers at the close of April is this: if galaxies grew and collided to shape the Milky Way, what happened inside our own? How did this galaxy eventually spin out a tiny system of planets, including one blue world that would carry oceans, forests, and eventually us? By the time May arrives on the cosmic calendar, the Milky Way is no longer a fragile young galaxy. It has grown strong through mergers and collisions, its spiral arms stretching outward like vast highways of stars. The galaxy hums with activity. Stars are born in clouds of gas. Stars die in blazing explosions, and black holes at the center feed quietly, shaping the currents of the galaxy. It is within this galaxy, during the month of May, that something remarkable begins, the early whispers of our own solar system. Imagine a cloud of dust and gas, left behind by generations of dying stars, slowly swirling in space. At first, it is nothing but a vague patch, a faint smudge among billions of others. But under the pull of gravity, the smudge begins to spin, flattening into a disk. At its center, material collapses into a fiery ball, the infant sun. The sun was not born politely. Like all stars, it roared into existence. Its ignition was the moment hydrogen atoms began fusing into helium at its core, releasing an energy that would shine steadily for billions of years. Think of a lamp being switched on in a dark room. The sun lit its neighborhood, and it has burned ever since. It is still burning tonight, providing you with the warmth that makes your very heartbeat possible. Around this newborn star, the spinning disk of dust and gas became a nursery for planets. Clumps formed, colliding and sticking, growing larger each time. Some of these clumps were flung away by gravity, lost forever into the black. Others endured, gathering more and more mass until they became spheres. This was the slow, chaotic dance that gave us Mercury, Venus, Earth, and Mars in the inner zone, and the giants Jupiter and Saturn further out. But don't imagine this as a calm process. May was a month of violence. Protoplanets slammed into each other with such force that entire surfaces melted. One collision, unimaginably massive, struck the young Earth and tore off a piece of it. That debris gathered into what we now call the Moon. So when you look at the Moon hanging quietly in the night sky, remember, it is a scar, a reminder of the violence of May. This era is sometimes called the heavy bombardment, and the name is not an exaggeration. For millions of years, or on our calendar, days and weeks, the young Earth was pummeled by asteroids and comets. The surface boiled, oceans of lava spread, and yet these very impacts may have delivered the first water to our planet. The gentle waves that now lap against beaches are echoes of May's collisions, frozen in time. While Earth struggled through this chaotic childhood, something else was happening. The chemistry of life was being prepared. Those collisions and impacts brought not just water, but also organic molecules, the basic building blocks of biology. Carbon compounds, amino acids, and other precursors drifted down with comets, mingling with the hot rocks and oceans of the young world. It was as though the recipe for life was being sprinkled across the planet, waiting for the right moment to simmer. The sun itself, though steady, was not always kind. In its youth, it burned hotter and more fiercely, sending out solar winds that blasted away lighter gases. Planets like Mercury and Mars lost much of their atmospheres under this onslaught. Earth, shielded by its magnetic field and size, held on. That thin blue layer of atmosphere, which we take for granted each time we breathe, was a hard-won prize from May's battles. Meanwhile, Jupiter and Saturn played their own roles in shaping the system. Their massive gravity acted like cosmic guardians, flinging many dangerous asteroids out of the inner solar system. At the same time, they sometimes nudged other objects inward, sending them crashing into Earth. They were both protectors and threats, like giants tossing stones across a field. Without their influence, Earth might have been either barren or utterly destroyed. Pause for a moment and think of this. May is when the Earth itself began. Every mountain you see, every grain of sand, every drop of ocean water traces back to this month on the cosmic calendar, and yet, life itself still did not exist. All of May was spent building the stage, hammering the boards, setting the props. The play had not yet begun. When you lie in bed tonight, picture that young Earth, a molten world glowing red, skies filled with ash and smoke, oceans forming as steam cooled, lightning striking into pools of chemical-rich water. It was a planet that looked nothing like the calm blue marble you know, and yet it was your planet. You are tied to that molten, hostile May Earth just as much as you are tied to the forests and cities of today. The moon's creation, too, deserves lingering thought. It stabilizes Earth's tilt, keeping our climate steady enough for life to thrive. Without it, seasons might have been chaotic, and the story of life could have unfolded very differently, or perhaps not at all. In that sense, the moon is not just a satellite. It is a partner in the survival of life. You owe your existence to an ancient collision that seemed, at the time, nothing but destruction. And so May drifts toward its end, with the sun shining steadily, the planets in their orbits, and the Earth slowly cooling from its fiery youth. The bombardments would continue into June, but by now the solar system had its structure. The stage was ready, the props were in place, the curtain was waiting to rise. The question that hangs in the air is this. Once the Earth cooled, once the oceans settled, how long would it take before life, even the simplest forms, appeared? If May was the month of fire and collision, June is the month of water and patience. By now, Earth has survived its violent childhood. The endless pounding of asteroids has begun to ease. The molten surface is cooling, and oceans are spreading across its face. Steam that once choked the skies condenses into rain, falling for thousands upon thousands of years, filling basins, carving valleys, creating seas. Imagine a planet where rain never stops, where the sound of water is the only sound. That was Earth in early June. From space, this young Earth would have looked both familiar and alien. Blue oceans already shimmered, but the continents we know had not yet formed. Instead, the surface was dotted with volcanic islands, constantly reshaped by eruptions. The atmosphere was thick with gases like methane and carbon dioxide, tinged orange or red. To breathe, it would have been impossible for you, but for the first chemistry of life, it was the perfect laboratory. June is the month when the ingredients delivered by May carbon compounds, water, energy from lightning, and volcanoes began to assemble themselves into something greater. At first, it was not life as we imagine it. There were no cells, no creatures swimming or crawling. Instead, it was molecules experimenting with structure. Chains of amino acids linked together, forming proteins. Strands of nucleic acids began to carry information, to copy themselves, to make tiny mistakes, and improve through those mistakes. It was chemistry learning to become biology. And here is a thought that can quiet your mind. The very first ancestor of you, of me, of every tree and bird and insect, was not a creature at all. It was a self-replicating molecule floating in a warm little pool, perhaps struck by lightning or warmed by geothermal heat at the bottom of the ocean. Something so small, so insignificant, that it could barely be called alive. Yet from that humble spark grew forests, oceans teeming with life, and the thoughts you are having now. The origin of life is one of the most mysterious stories in all of science. We do not know the exact day in June when it happened, nor the precise place. Some say it began in shallow pools where sunlight and evaporation concentrated chemicals. Others believe it began deep under the sea, at hydrothermal vents where hot water spews from cracks in the Earth's crust, rich in minerals. Either way, life began not in grandeur, but in hidden corners, tiny, unnoticed, fragile. And once it began, it was astonishingly persistent. Early life forms were simple microbes, little more than bubbles of fat containing strands of molecules. But these bubbles could divide, copy themselves, and compete. Slowly, over the long days of June, they spread across Earth's oceans. They did not need oxygen. They thrived in conditions that would kill you instantly: boiling water, acidic pools, toxic gases. For them, this was paradise. Now, imagine lying in bed tonight, drifting half asleep, and trying to picture those first microbes. They had no eyes, no brains, no sense of the future. They did not know they would someday give rise to dinosaurs, or to cities lit with electricity, or to a person listening quietly to a story like this. They existed because they could, nothing more. Yet in their persistence, they began to shape the Earth itself. By mid-June, life had spread enough to leave traces behind. Fossil evidence of ancient microbes, trapped in rocks, tells us that life emerged quickly once the planet stabilized. In cosmic terms, it was as if the moment Earth was ready, life appeared almost immediately. It is as though the universe had been waiting for this stage to begin, and the script wasted no time in turning chemistry into biology. One of the dull but extraordinary details is this: almost all of June is ruled by microbes. Not animals, not plants, not anything with a face or limbs, just microbes. For billions of years on the real timeline, or the whole stretch of June on the cosmic calendar, Earth was a microbial world. If you had visited then, you would have seen nothing larger than a film of slime on a rock, or tiny shapes under a microscope. Yet those microbes were already at work, experimenting, innovating, preparing the way for everything else. Some microbes discovered how to capture energy from sunlight, a process we call photosynthesis. At first, they used it simply to grow and multiply, but their activity began to release oxygen into the air slowly, invisibly, molecule by molecule. Oxygen was poisonous to most early microbes. Many died, but others adapted. This simple innovation, turning sunlight into energy and releasing oxygen, would change the entire planet. Though the Great Oxygen Revolution belongs to August on our calendar, its seeds were sown in June. The first whispers of oxygen began then, unnoticed, uncelebrated. The microbes that released it could not have imagined that, billions of years later, their waste gas would fill the lungs of creatures who walk, think, and tell stories. Pause here and consider what June really represents. It is not dramatic like the fiery birth of the universe in January, nor violent like the collisions of May. It is quiet, slow, almost dull. But it is the quiet of a seed germinating underground, unseen. The Earth was preparing in silence, building the foundation of all future life. Without June, there would be no forests, no animals, no us. This makes me wonder, and perhaps you too, about patience. The universe is never in a hurry, yet it never stops creating. If life could begin in June, out of nothing but chemistry and time, then what other hidden beginnings might be happening right now, unnoticed, in the vastness of space? If June was the month of first beginnings, July is the month of endless repetition. The Earth in July looked calm compared to the firestorms of May, but it was alive in ways that would have been invisible to your eyes. Across oceans and pools, microbes multiplied, divided, and drifted. They were tiny architects, working silently, building the foundation of the biosphere. For nearly all of July, life remained microscopic, and yet what these little organisms accomplished was nothing less than the reshaping of a planet. Imagine dipping a jar into an ancient July ocean. To you, it would look like plain water, perhaps a little cloudy, but under a microscope, you would see countless shapes wriggling and floating spheres, rods, spirals, some clustering together, others drifting alone. Each of them was alive, each copying itself again and again. Most of them had no greater purpose than surviving, but in their stubborn survival, they changed the chemistry of the seas, the air, and the land. One of the extraordinary but quietly dull truths is this: For billions of years on the real timeline, or the entire stretch of July in the cosmic calendar, microbes were the dominant life form. Dinosaurs, fish, trees, even insects are newcomers compared to them. If you were to measure the history of Earth by success alone, microbes would win by every standard. They adapted to every corner, from boiling vents at the bottom of the sea to icy rocks. Even now, in your own body, trillions of microbes live inside you, reminding you that July never truly ended. Some of these July microbes began to do something astonishing. They learned how to harness sunlight more efficiently. The earliest experiments with photosynthesis had already begun in June, but in July the practice spread. With it came oxygen, released as a byproduct. At first, this oxygen floated unnoticed into the atmosphere, a trace among heavier gases like carbon dioxide and methane. But slowly, relentlessly, molecule by molecule, the levels began to rise. It is strange to think of oxygen as dangerous, but to most early life forms, it was toxic. July was full of microbes that could not survive in oxygen-rich conditions. As the gas accumulated, they retreated into oxygen-free niches, deep underground, inside sediments, or in isolated pools. Many perished. And yet, other microbes discovered ways to use oxygen for energy. This innovation would, much later, fuel complex life like animals. But for now, it was simply another microbial experiment, unnoticed and quiet. While the atmosphere was being altered invisibly, the oceans of July were busy making landmarks that still exist today. Some microbes clustered together in colonies that grew into rocky structures called stromatolites. Layer upon layer, they built domes and mounds, trapping sediments, creating living rock. If you were to walk along an ancient shoreline in July, you might have seen strange, lumpy reefs rising out of the shallow seas. These were built entirely by microbes. And astonishingly, some stromatolites still exist today in remote parts of the world, like Shark Bay in Australia. They are living fossils, survivors from July, still breathing out oxygen into the 21st century. Picture yourself beside such a reef, running your fingers across its rough surface. You are touching something that has persisted for billions of years, something older than trees, older than fish, older than bones. The quiet builders of July are still here, whispering across time. And while microbes ruled Earth, the planet itself was changing. The crust thickened, the continents began their slow, endless drift. Volcanoes still erupted, but less violently than in May. Mountains rose and crumbled. Rivers carved channels into rock. The Earth was restless, always reshaping, but within that restlessness, life adapted easily. Microbes did not care if the continents shifted. They simply found new corners to inhabit, new vents to cling to, new waters to swim in. This patience is what makes July remarkable. Nothing spectacular happens if you look for drama. No creatures appear to crawl or leap. No forests rise. But if you look for significance, July is full of it. The planet was being transformed molecule by molecule, cell by cell. The oceans became saturated with life. The atmosphere began its long, slow march toward oxygenation. By the end of July, Earth was no longer a lifeless rock spinning around the sun. It was a world of chemistry reshaped by biology. Perhaps the most grounding thought is this: you are descended from July. Every cell in your body carries the echoes of those microbes. The way your cells produce energy, the way they divide, the way they use oxygen, all of it comes from experiments perfected billions of years ago by July organisms. They invented the very processes that keep you alive. You are their continuation, their legacy, their unwitting heir. So while you lie quietly, drifting towards sleep, remember that life does not always need to be dramatic to matter. July is proof of that. The microbes did not roar into existence with grand gestures. They multiplied slowly, changed the planet invisibly, and laid the groundwork for everything else. And that leaves us with a lingering question. If July was the month of persistence, and August is when oxygen truly takes hold, how does a planet already alive prepare itself for a revolution in its atmosphere? What happens when the waste gas of microbes reshapes the fate of the entire biosphere? August on the cosmic calendar begins not with a bang, but with a breath. To you, it would have been just air, invisible and tasteless. But for life on Earth, it was a poison and a promise. The great oxygenation had begun. Think of the Earth in early August. The skies were not yet the familiar blue, you know. Instead, they were hazy, tinted by methane and other gases. The oceans, too, were strange. Instead of clear blue waters, they may have been greenish or reddish, stained by dissolved iron and sulfur compounds. This was a world still in transition, but something remarkable was brewing. Tiny organisms, cyanobacteria, had been quietly perfecting the art of photosynthesis. By capturing sunlight, they released oxygen into the oceans and the atmosphere. For millions upon millions of years, this oxygen had been absorbed by rocks and minerals, reacting with iron to create rusty layers on the ocean floor. Geologists still find those layers today in what are called banded iron formations, stripes of red and grey stone, relics of August written into rock. But by early August, the sinks that swallowed oxygen were filling up. The Earth could no longer hide what life was producing. Slowly, the levels of oxygen in the atmosphere began to rise. To you, a few percent might not sound like much, but to ancient microbes, it was catastrophic. For many organisms that had thrived in oxygen-free environments, this new gas was deadly. They retreated into isolated pockets, deep underground, beneath sediments, or in stagnant pools where oxygen could not reach. Entire populations dwindled and disappeared. It was, in effect, one of the first mass extinctions in Earth's history. And yet, extinction for some meant opportunity for others. A few organisms discovered that oxygen could be used, not avoided. They learned to harness its power in chemical reactions, extracting far more energy from food than their ancestors ever could. This innovation, aerobic respiration, would eventually allow cells to grow larger, more complex, and more capable. August was a training ground for future possibilities. The change in atmosphere also altered the planet itself. With methane declining and oxygen increasing, Earth's greenhouse effect weakened. Temperatures fell. Ice crept outward. Some scientists suggest that during parts of August, Earth may have been gripped by a snowball state, where ice stretched nearly to the equator. Imagine looking at Earth from space. Instead of a blue marble, you might have seen a white orb, frozen and reflective. Life survived in cracks beneath the ice, in vents at the ocean floor, in tiny liquid refuges. The August Earth was fragile, yet persistent. Now, picture yourself standing on one of those icy coastlines in August. The air is thin, the winds sharp, the waters locked under a shell of ice. And yet, beneath your feet, in microscopic worlds invisible to your eyes, life continues. In tiny bubbles of liquid water, microbes adapt. They find ways to endure the cold. Some even thrive, producing energy in ways unimaginable to creatures that would one day walk the earth. There is something almost humbling about August. For billions of years before this point, Earth had been ruled by chemistry and simple biology. Now, the chemistry was changing because biology demanded it. The waste of one form of life, oxygen, became the foundation for everything else. The planet itself had been re-engineered by tiny organisms that never intended to do anything grand. Their metabolism, repeated across countless cells, had rewritten the rules of survival. It is worth pausing here and asking yourself, how different is that from us? You, sitting or lying in the quiet of your room, are also altering your planet without intending to. Each car ride, each factory, each glowing screen produces gases that change the atmosphere. The difference is scale and awareness. The microbes of August did not know they were reshaping their world. You, at least, have the choice to notice. By mid-August, the rise of oxygen had created new habitats. Shallow seas sparkled with light and oxygen, offering opportunities for cells to grow larger. It was in these conditions that a partnership began, a quiet alliance that would change everything. Some cells swallowed other cells, not as prey but as companions. Instead of digesting them, they kept them alive inside, harnessing their abilities. This was the origin of mitochondria, the tiny powerhouses inside your cells today. Every breath you take, every heartbeat, every step you walk relies on energy made possible by that ancient August partnership. It is almost poetic. One cell became two in spirit, a host and a guest, bound together forever. Without this symbiosis, complex life would never have emerged. Animals, plants, fungi, all of them trace back to this moment of cooperation. In August, the blueprint for multicellular life was written, even if it would take months more on the calendar to unfold. Meanwhile, the Earth's landscapes continued their slow rearrangement. Continents gathered and drifted, mountains eroded, oceans widened. Lightning still cracked across skies, volcanoes still erupted, comets still occasionally struck. But through it all, life endured. What seemed like a hostile environment, ice, shifting gases, toxic oxygen, became the crucible in which resilience was tested. If you were drifting through space during August, watching Earth from afar, you might have mistaken it for a barren world. No forests, no animals, no green continents, just oceans, ice, and clouds. And yet, hidden in every corner, life persisted. The planet was preparing itself for greater things. There is something comforting in that thought. Progress does not always look impressive. Sometimes it is slow, invisible, unnoticed. Sometimes it is nothing more than a cell dividing in a bubble of water under a sheet of ice. And yet, from those unnoticed acts, everything else grows. And so August closes not with a spectacle but with potential. The Earth now had oxygen. It now had cells learning to cooperate. It had endured ice and catastrophe, and had come out more prepared than before. The stage was set for complexity, though it would still take time. As you settle deeper into sleep, you might ask yourself, if oxygen was once a deadly poison, what in your own life feels like a burden today that might one day turn out to be a foundation? By the time September begins, Earth has already endured billions of years of quiet struggle. Entire oceans have frozen and thawed, skies have shifted from toxic haze to oxygen-rich blue, and single cells have learned to cooperate in ways that made survival easier. But here in September, something new emerges, a bold experiment in size, shape, and structure. Life begins to go multicellular. Picture September 1st on this calendar year. The oceans are alive with invisible communities of microbes, each one humming along in its microscopic world. They float in the water, cling to rocks, or drift in mats across the sea's surface. For ages, this was all life had been. But now, in a few places, cells begin to stick together, not just temporarily, but permanently. At first, the clusters are small, perhaps just a few cells clinging after division, reluctant to part. Yet this simple act changes everything. For the first time, organisms can divide labor. Instead of every cell doing everything, some cells begin to specialize. One might take in nutrients, another might move the group, another might reproduce. The burden of survival is no longer carried by one, but shared among many. To you, this may sound obvious, of course, living things cooperate. But in September, it was revolutionary. It was the moment life decided that being alone was not enough. By mid-September, these experiments begin to bear fruit. Strange, soft-bodied organisms drift across the ocean floor, anchored in place, or slowly gliding across the mud. These are the Ediacaran organisms, named much later after rocks in Australia where their fossils were found. They had no bones, no shells, no teeth, just soft, quilt-like bodies shaped like discs, fronds, or even fern-like leaves. If you were to swim through those seas, you might think you were drifting through a garden at twilight, the seafloor covered in strange, motionless shapes that swayed gently in the currents. The Ediacaran world feels almost dreamlike compared to what would come later. There were no predators yet, no chasing, no biting. These creatures lived simple lives, absorbing nutrients, filtering water, or harvesting sunlight through symbiotic microbes in their tissues. It was a peaceful community, if alien to our eyes. Imagine yourself sitting by the shore in September. The air is cleaner now, the sky is more familiar. If you looked into a tide pool, you might see mats of microbes forming slimy green sheets, while deeper down, delicate fronds waved like submerged banners. The seas were no longer empty, they were beginning to bloom. And yet, even in this quiet, the stage was being set for drama. With multicellularity came new possibilities: movement, size, strength, hunger. By late September, some organisms learned to burrow into the sediment, leaving the first tiny trails and tunnels behind. This was more than play. Burrowing allowed creatures to escape harsh conditions, to find food buried below, to avoid being smothered by debris. For the first time, animals were actively shaping their environment, stirring up the mud, mixing oxygen into deeper layers of the sea floor. It was also the beginning of an arms race. Once one organism could move, another might evolve to follow. Once one could burrow for food, another would need to dig deeper. September was still peaceful by comparison, but hints of competition were emerging. Meanwhile, the Earth itself continued its restless activity. Continents drifted and collided, mountains rose and wore down, oceans shifted their borders. In some regions, nutrients poured into the seas from eroding rocks, fueling the growth of microbial mats and larger organisms alike. In others, the seas were quiet, almost barren. Geography shaped evolution, just as it does for humans today. If you were to walk the shores of September, you might notice something unsettling. The land, though barren, was not silent. Cracks in the earth vented gases from volcanoes, winds howled across rocky plains, and occasional lightning split the sky. But there was no green, no forests, no grass beneath your feet. The continents were still lifeless. All of September's wonders remained confined to the oceans. Think for a moment about how strange that would feel. On your calendar year, Earth, humanity does not arrive until the very last night of December. Forests and jungles, birds and mammals, even insects, all of that is still far away. September is a world where the ocean floor is the center of drama, and the land is just a backdrop, waiting for its turn. By late September, the pace quickens. Oxygen continues to build in the seas and air, and organisms respond. Some grow larger, feeding on microbes or absorbing energy from sunlight more efficiently. Others begin to form the first hints of skeletons, tiny mineralized structures in their bodies that gave them support. These were not yet bones as you know them, but they were a preview of what was to come. For the first time, nature experimented with hard parts, the scaffolding on which future bodies would be built. It is easy, perhaps, to overlook September. Compared to the drama of dinosaurs or the invention of fire, what are a few soft-bodied creatures and microbial mats? But without September, there would be no future drama at all. It was here that life learned to scale upward, to collaborate, to endure. There is something quietly inspiring about this. You may not notice your own small steps in daily life, the habits you form, the tiny adjustments you make. Yet, as September shows, the smallest changes can rewrite the future. A few cells deciding not to separate after division seems trivial, but it became the difference between a world of microbes and a world of whales, forests, and human beings. As September closes, Earth stands at the brink of something remarkable. The oceans are no longer filled with only the invisible. Now, they host communities of larger, stranger forms, living in ways that had never been tried before. The land waits, empty and silent, but it will not wait forever. And so, as you drift deeper into thought, ask yourself, if September was a world of experiments, what quiet experiments are happening in your own life right now? Experiments that may seem unimportant, but could one day change everything. October begins not with silence, but with a quiet anticipation. For billions of years, life has been small, soft and limited, little more than microbial mats and a few soft-bodied fronds swaying in the oceans. But with the turn of October's page, something extraordinary happens. The world does not simply evolve, it erupts. This moment, known to us as the Cambrian explosion, marks one of the greatest transformations in life's story. It happens in a blink of geological time within a few tens of millions of years. The oceans change from sparsely populated gardens to bustling, competitive ecosystems. If September was a slow, dreamy overture, October is the sudden crash of cymbals in a long symphony. By early October, creatures with shells, skeletons, and teeth appear for the first time. Imagine how alien this must have felt to the soft-bodied organisms of September. For hundreds of millions of years, they had lived without fear of predators. But suddenly, the seas are filled with hunters, armed with claws and jaws, and prey protected by armor. The balance of life shifts forever. One of the stars of early October is trilobites, small arthropods with hard exoskeletons that scuttled along the seafloor. Picture them like ancient horseshoe crabs, their segmented bodies gleaming in the filtered sunlight. They could roll up into tight little balls for protection, just as pillbugs do today. Trilobites would dominate the oceans for hundreds of millions of years, leaving behind an immense fossil record that still tells their story in stone. But trilobites were not alone. There were spiny worms, early mollusks, and creatures so bizarre they challenge imagination. One, called Anomalocaris, could grow to several feet long, making it a true giant of its day. With grasping appendages and a circular toothed mouth, it swam through the water like a nightmare of the Cambrian seas. If you could float above the ocean floor in October, you might see an Anomalocaris gliding past, its body rippling with undulations, its grasping limbs ready to seize prey. At the same time, new forms of defense appeared. Some animals grew spines, others developed hard shells of calcium carbonate. A few burrowed deeper into the sediment to escape predators. The game of survival became more complex, more dynamic. Every adaptation inspired a countermeasure, and in that back and forth, evolution accelerated. By mid-October, ecosystems emerge that feel strangely modern. There are predators and prey, grazers and scavengers, swimmers and burrowers. The ocean floor is no longer a sleepy carpet of microbial mats, but a vibrant battlefield of life, teeming with movement. It was here, in October, that the modern rules of ecosystems were written, and yet, if you were to drift through these seas, you would notice how alien it all still felt. Creatures had body plans unlike anything alive today. Some had 5 eyes, others had long spines trailing behind them. Still others seemed like patchworks of features, as if nature were experimenting with every possible form. Many of these designs would vanish without descendants, leaving only fossils as evidence that they ever existed. There is something humbling in that, to realize that our own bodies, our lungs and limbs and eyes, are the survivors of countless experiments. Evolution tried 1,000 different ways to build life, but only a handful endured. When you stretch your hand or blink your eyes, you are carrying forward the legacy of October's successful designs. The Cambrian explosion also left behind one of the richest fossil deposits in the world, known as the Burgess Shale, found in the Canadian Rockies. Within these rocks are snapshots of October's strange creatures, preserved in exquisite detail, their soft bodies, their delicate appendages, even their stomach contents. From these stones, scientists can peer into a world 500 million years gone, where a simple ocean floor buzzed with activity that rivaled any coral reef today. Meanwhile, Earth itself kept shaping the stage. Continents drifted across the globe, and shallow seas spread across wide areas, providing fertile ground for life to expand. Sunlight penetrated these waters, fueling algae, which in turn fed a rising web of grazers, which then fed predators. Nutrients washed in from rivers and eroding mountains, enriching the seas even more. It was a planet in transition, restless, fertile, alive. And yet, for all the complexity of October, the land remained silent. The continents were still barren, with no plants to hold the soil, no insects to crawl across the rocks, no trees to sway in the wind. All the drama remained confined to the oceans. The land was a desert, waiting patiently for its turn in the story. Sometimes, when scientists describe the Cambrian explosion, they note how sudden it seems. In geological terms, a few tens of millions of years is little more than a blink. To you, lying in bed and listening now, this might feel strange. How could such complexity appear so suddenly? The answer lies partly in the foundations laid during September: multicellularity, oxygenation of the seas, the evolution of simple skeletons. October was not a miracle out of nowhere. It was the inevitable bloom of seeds planted long before. Perhaps you can relate this to your own life. Sometimes changes feel sudden: a new job, a new friendship, a moment when everything shifts. But often, the groundwork has been laid quietly for years, in small habits, unnoticed decisions, or silent patience. October reminds us that explosions of progress rarely come from nowhere. They are the harvest of long preparation. As October draws to its close, life has transformed forever. The oceans are crowded, diverse, and competitive. The rules of survival are more complex than ever before. Predation, armor, mobility, vision, all of these have entered the game. The soft, quilted organisms of September now seem almost quaint, overshadowed by the armored, mobile, and aggressive creatures of October. And yet, even with all this change, the story is only beginning. Life has conquered the oceans, yes, but it has not yet stepped onto the land. Plants have not yet painted the continents green. Vertebrates are still small and primitive. October's oceans are rich, but the earth holds greater transformations ahead. So as you let your thoughts drift, consider this. If October was the month when the rules of ecosystems were written, what new rules might still emerge in the future? Could life, even now, be preparing for another explosion of possibilities, one that we cannot yet imagine? November begins with a quiet tension. For half a year now, life has flourished in the oceans, from microscopic cells to the armored, mobile creatures of October. The seas are teeming with fish-like organisms, worms, trilobites, and early arthropods, all playing their roles in complex ecosystems. But the land remains barren, dry, rocky, and lifeless. The challenge for life is immense. How do you leave a medium where buoyancy supports your body, where water carries nutrients, and step onto a world where gravity is stronger, where moisture is scarce, and where ultraviolet sunlight can burn without the protection of water? Early November marks the first experiments in terrestrial colonization. Tiny organisms, mostly plants and fungi, begin to crawl onto land in shallow, damp areas. They cling to rocks, riverbanks, and the edges of ponds. Moss-like plants start the slow process of breaking down rock into soil. Fungi form symbiotic partnerships with these pioneers, helping them extract nutrients. The land, which had been lifeless and inert, begins to respond to these tiny intrusions. It softens, it retains water, it begins to hum with potential. In the oceans, vertebrates are growing more sophisticated. By mid-November, fish with primitive jaws and paired fins dominate the shallow seas. Some of these fins begin to stiffen, hinting at the structures that will eventually allow movement on land. Evolution is experimenting quietly, almost imperceptibly, preparing for the moment when gravity will matter more than buoyancy. Meanwhile, the climate of November is variable. Continents drift, mountains rise and erode, and shallow seas come and go. Ice caps may expand and contract, but large regions of land remain stable enough to provide stepping stones for the first terrestrial life. Rivers carry nutrients from the mountains, depositing fertile sediments where the earliest plants can take root. Life is patient, persistent, and opportunistic. The first land animals are small arthropods, like millipede ancestors. Venturing onto the damp forest floors that begin to appear, they are cautious, moving only when conditions are favorable, retreating to the moisture of leaf litter or underground burrows during dry periods. November's early explorers are tiny, fragile, and easy to overlook, but they mark a monumental shift. Life is no longer confined to the oceans. It is beginning to challenge the land itself. By mid to late November, The first vascular plants, those capable of transporting water internally, start to evolve. These plants are still simple, but they can grow taller and spread across the land more efficiently. With them comes a change in the atmosphere. By pulling carbon dioxide from the air, these early plants begin to subtly modify the climate. Earth is, in a very real sense, learning how to regulate itself in preparation for more complex life. If you could walk through November's early forests, it would be a world of strange textures and muted colors. There are no flowers yet, no trees with leaves reaching skyward. Instead, you see low, carpet-like plants, clinging mosses, primitive stems, and the occasional spore-bearing structure releasing clouds of tiny reproductive units. The air would feel heavy with moisture, the soil soft and rich with organic material, and the quiet hum of tiny insects and arthropods filling the air. In the oceans, the evolutionary experiment continues. Jawed fish diversify, giving rise to lineages that will eventually seed amphibians. Coral reefs begin to flourish, providing habitat for countless species. Predation drives specialization. Armor becomes more sophisticated, fins develop more precisely, and early sensory organs evolve to detect movement and chemical signals. Life is still confined to water, but the push toward land is irresistible. By late November, the first true amphibians, vertebrates capable of venturing onto land for brief periods, make their appearance. These creatures rely on water for reproduction, laying eggs in ponds or rivers. They must return to the water frequently, yet their arrival marks a fundamental shift. Land is no longer a barrier, it is a new frontier. These pioneering amphibians begin to explore riverbanks, shallow marshes, and tidal flats. Every inch they conquer is a blueprint for future vertebrate evolution. The importance of November cannot be overstated. For the first time, life is truly multi-environmental. It exists both in the seas and on land, testing the limits of biology, reshaping ecosystems, and laying the foundation for the forests, deserts, and grasslands that will come later. Every innovation, vascular tissue in plants, lungs in vertebrates, limbs capable of bearing weight, is being written into the genetic record during this month. And yet, for all its significance, November remains a quiet month compared to the spectacle of December. There are no large forests stretching endlessly, no herds of dinosaurs, no humans. Life is still small, cautious, and humble, yet the stakes are monumental. This is the month when the world begins to resemble the Earth you know today, even if in miniature and invisible to casual eyes. It is also a month of patience. Evolution is not a race, and November is proof of that. Life advances incrementally, one adaptation at a time, testing possibilities in isolation before committing fully. The seas teem with predators and prey, while land life tiptoes forward. The quiet persistence of November shapes all future months. Without these first explorers, the dramatic flourishing of December, from giant reptiles to mammals to humans, would never occur. So, as you drift deeper into thought, consider this. November teaches that greatness often begins in quiet, unnoticed steps. The first land plants, the earliest amphibians, tiny arthropods venturing into leaf litter, they all paved the way for everything that followed. Sometimes, the smallest and most patient actors leave the largest legacy. And now, as November closes, Earth is poised for a transformation that will culminate in the richness of life that dominates December. Life is ready to claim the land, to grow larger, and to explore every niche. The stage is set, the script is written, and evolution is about to unfold in ways that will astonish the planet, and, eventually, us. December begins with a quiet but relentless drive toward complexity. The world has already been shaped by billions of years of microbial experiments, multicellular innovations, and the first forays onto land. By the start of the month, forests of primitive plants cover continents, rivers carve fertile valleys, and the air is rich with oxygen. The stage is ready for dramatic life forms to fill every available niche. The early days of December are dominated by giant insects and amphibians. Some insects reach sizes that would seem impossible today, their exoskeletons thickened by high oxygen levels. Dragonflies the size of modern hawks soar above swampy forests. Amphibians with powerful limbs move confidently across shallow waters and land, laying eggs in ponds that glimmer under the early December sun. By the second week of December, the first reptiles appear. Unlike their amphibian ancestors, they are no longer tied to water for reproduction. They lay eggs with protective shells, enabling them to colonize drier regions. This innovation is monumental. It allows vertebrates to explore new habitats and grow larger. The stage is being set for future giants, the creatures that will dominate the planet for millions of years. Throughout mid-December, the world is a balance of chaos and beauty. Forests of towering ferns, horsetails, and early conifers stretch across the continents. Rivers teem with fish and amphibians, while the skies are alive with insects. Predation drives constant adaptation. Some creatures develop armor, others develop speed, still others develop cunning strategies for hunting or hiding. Life is no longer slow and experimental. It is competitive, dynamic, and diverse. Around December 25th late evening, the age of dinosaurs begins to dawn. Massive reptiles emerge, some walking on 2 legs, others on 4. They dominate the land, shaping ecosystems with their presence. Giant sauropods stretch their long necks to reach treetops, while fierce theropods hunt with precision. The skies host early flying reptiles, gliding and soaring above the forests. December is no longer the patient month of microbes or cautious amphibians. It is the age of spectacle, scale, and drama. By December 28th, the first mammals appear, small and nocturnal, living in the shadow of giants. They are clever survivors, burrowing and hiding, evolving the intelligence and adaptability that will one day allow their descendants to inherit the Earth. This is the quiet but crucial thread running through the end of December. Even when dinosaurs dominate, life prepares the groundwork for future revolutions. The final hours of December accelerate at a breathtaking pace. By December 31st, early birds soar, mammals diversify, flowering plants spread across continents, and primates evolve. And here is where you come in. Humans arrive only in the last hour of the year, around 11:59 p.m., mere minutes before midnight. For the vast majority of Earth's history, 11 months and 59 minutes of our cosmic calendar, humans did not exist. We are incredibly recent arrivals in a universe that has been in motion for billions of years. Consider the perspective this gives you. For nearly a year, life experimented, evolved, and thrived without humans. The first microbes, multicellular organisms, fish, amphibians, reptiles, dinosaurs, and mammals all existed long before we ever stepped onto the stage. By the time humans appear, the world is already rich with complexity, beauty, and history. We inherit a planet shaped by countless generations of life and countless changes of environment, atmosphere, and geology. Even the last minutes of December are filled with pivotal moments. Early humans develop tools, fire, and social structures. Civilizations rise and fall in the blink of a cosmic eye. Dinosaurs, glaciers, mountains, and oceans have already set the stage for what is possible. As the clock ticks toward midnight, everything familiar to us, forests, deserts, rivers, cities, emerges. In these final minutes, human history condenses millions of years of evolution into something we can recognize, yet it is still only a tiny fraction of the year-long history of the universe. Reflecting on this, the scale is humbling. Imagine a party that lasts all year. Dinosaurs appear in late December, early humans at 11:59 p.m., and we spend only seconds of cosmic time in the grand story of Earth. Every invention, every art piece, every scientific discovery comes in those last few seconds. The universe has been patient, and we are fleeting. There is beauty in this brevity. It reminds us to be conscious of the present, to cherish the fleeting time we occupy, and to respect the deep history that preceded us. Every ocean wave, Every mountain, every cell in your body carries the legacy of billions of years. You are both a product of that history and an observer of it, bridging the gap between cosmic time and human time. Even as humans arrive, the planet continues to evolve. Ice ages sweep across continents, shaping the landscape. Extinctions purge ecosystems, making room for new forms. Civilizations rise, alter environments, and leave traces of their presence. The universe is still vast and ancient, and even the most recent chapters are only whispers in the greater story. December teaches patience, perspective, and humility. It reminds you that while humans may dominate the present moment, we are newcomers on a stage built over billions of years. The universe is vast, complex, and indifferent to our existence, yet it has provided the conditions for life, curiosity, and consciousness. And within the final minutes of this cosmic calendar, we glimpse both our significance and our smallness. As you settle into sleep, imagine this timeline. The Big Bang on January 1st, galaxies forming in the spring, Earth emerging in May, life quietly stirring in June and July, oxygen transforming the seas in August, multicellular life appearing in September, the Cambrian explosion in October, the first land life in November, and all of human history compressed into the last minute of December 31st. The question that lingers, even as you drift off, is this: if we are such recent arrivals, what legacy will we leave behind in the cosmic story? Will humans, who appear only in the final minute, make an impact that echoes beyond our fleeting hour? Or will we simply be another experiment in a universe that has seen countless forms of life come and go? By the time the clock on our cosmic calendar ticks toward the final minute of December 31st, humans have finally arrived. For nearly a full year, the Earth has been a laboratory of life, vast oceans teeming with ancient creatures, continents shaped by ice and fire, forests, deserts, and mountains evolving patiently over billions of years. And now, in the last 60 seconds, humans step onto a stage that has been set over eons. Picture this. It is 11:58 p.m. The first humans are wandering the planet. They are small in number, scattered across regions of Africa, adapting to their environments, discovering fire, learning to use tools. For almost the entirety of December, life has evolved without humans. Forests have grown, glaciers have shifted, oceans have surged, and now, almost imperceptibly, a new species begins its journey. In cosmic terms, we are latecomers. We are recent guests in a world that has existed for billions of years. In these final seconds, the first civilizations emerge. Agriculture begins, roughly 12 seconds before midnight. Imagine early humans planting grains, domesticating animals, clearing land for the first fields. For the vast majority of the year, humans were hunters and gatherers, surviving quietly in small groups. Now, for the first time, they are shaping landscapes on purpose. Forests are cleared, rivers are redirected, soils are tilled. This is the start of human influence on the planet. By 11:59 p.m., great civilizations rise. Egypt, Mesopotamia, Indus Valley, China, all of them appear almost simultaneously in the compressed timeline. Pyramids are built, temples rise, cities expand along rivers. Writing is invented, enabling knowledge to be stored and transmitted. Trade routes are established. Human culture begins to accumulate. In the grand scale of the cosmic calendar, these events take place in seconds, yet they carry the weight of millennia of history. As the seconds tick closer to midnight, human discovery accelerates. Classical Greece, Rome, and the empires of the Middle East and Asia emerge. Philosophy, mathematics, and astronomy are explored. The Renaissance and Enlightenment arrive almost instantaneously in cosmic terms. Paintings, literature, scientific discoveries, each is a brief flash in the final minute, but monumental in human understanding. The wheel, the compass, the printing press, vaccines, telescopes, microscopes, all are inventions that transform humanity's relationship with the world. By 11:59 and 45 seconds, the Industrial Revolution erupts. Steam engines, factories, and machines dramatically alter landscapes, societies, and the environment. Railways crisscross continents, coal is burned, and cities swell. Humanity now has the capacity to reshape the planet on a global scale. In the cosmic year, this occurs almost instantaneously, a fraction of a second, but it sets the stage for modern civilization. By 11:59 and 55 seconds, the modern era begins. Electricity lights cities, cars traverse landscapes, airplanes cross oceans, and computers connect the world in networks. The 20th century arrives, with its wars, inventions, and milestones. Humans land on the moon, send probes to other planets, decode the structure of DNA, and map the human genome all in the blink of cosmic time. Civilization is accelerating at a speed unimaginable compared to the slow march of evolution that dominated the previous 11 months. In the final 4 seconds of the cosmic year, we see the present day. Satellites orbit the Earth, smartphones connect billions of people, cities sprawl, and technology permeates every aspect of life. Humans are no longer just inhabitants of a planet shaped by nature. They are active participants, reshaping ecosystems, altering climates, and exploring the universe. These last 4 seconds represent millennia of human activity, compressed into a cosmic heartbeat. Consider the perspective. For 11 months and 59 minutes, humans did not exist. Dinosaurs rose and fell, continents drifted, oceans teemed with life. Forests and glaciers transformed landscapes, all without our presence. And yet, in the final minute, we emerge as both observers and actors, capable of altering the planet in ways no other species has before. The brevity of our existence in cosmic terms emphasizes both our fragility and our potential. It is humbling to realize how recently we arrived. The first Homo sapiens emerge in the last 45 seconds, and all of recorded human history occurs in the final 10 seconds. Ancient civilizations, written language, empires, global exploration, industrialization, and modern technology all are compressed into moments that, compared to the full year, are nearly imperceptible. This perspective invites reflection on both our accomplishments and the responsibility we carry. Despite our brief presence, humans have left undeniable marks. Cities, monuments, and infrastructure stretch across continents. Agriculture has transformed ecosystems. Dams, roads, and railways reshape waterways and landscapes. Human activity has begun to influence climate patterns and atmospheric chemistry. In a cosmic sense, the planet's history has pivoted in the last few seconds of December 31st, a rapid acceleration of influence unlike anything before. The final seconds also underscore the fragility of human existence. While we have power, technology, and knowledge, we are still subject to the same cosmic forces that have shaped life for billions of years. Asteroid impacts, volcanic eruptions, climate shifts, and changes in the sun's output. The universe has endured billions of years of transformation and will continue long after humans are gone. In the grand scheme, we are both fleeting and precious. There is also awe in our potential. In these last seconds, humans reach for the stars. Satellites orbit Earth, telescopes scan galaxies, and spacecraft explore planets and moons. We glimpse the cosmic calendar beyond our own year-long analogy, understanding that the universe is vast, ancient, and full of possibilities. Our brief existence, compressed into the final moments, is not merely a conclusion, it is an invitation to explore, learn, and imagine. December, and particularly its final minute, teaches profound lessons. First, the vast majority of time is spent preparing the stage. 11 months and 59 minutes of history occurred before we arrived. Second, even a brief presence can have enormous impact, for better or worse. Third, our awareness of time and consequence gives us the unique ability to reflect, plan, and act responsibly in the universe. As the cosmic clock strikes midnight, the year is complete. From the Big Bang on January 1st at 12 a.m. to human civilization in the final minute of December 31st, the journey has been remarkable. Galaxies form, stars ignite, Earth solidifies, life emerges, oxygen fills the seas, multicellular organisms evolve, the Cambrian explosion fills the oceans with complexity, life moves onto land, dinosaurs dominate, mammals rise, and finally, humans appear. All of it is a continuum of cause and effect, patience and persistence, experimentation and innovation. And so, as you lie quietly and drift towards sleep, reflect on your place in this story. Humans are recent arrivals in a universe that has been unfolding for billions of years. Yet, in the final seconds, we carry immense potential. Every thought, invention, and action resonates against a backdrop of cosmic time. We inherit a world shaped by endless processes, and in return, we shape the world in ways that future generations will inherit. Finally, ask yourself, if all of human history fits into a single minute of the cosmic year, what might the next second bring? How will our choices echo through the long story of Earth and the universe? And what possibilities remain, waiting to be discovered in the remaining hours, days, and months beyond this compressed calendar? As you settle in and let your thoughts drift, imagine looking back at the entire cosmic calendar, from January 1st at 12 a.m., the Big Bang, to December 31st at 11:59 p.m., the history of the universe unfolds before your mind like a story written across a single year. Each month marks a milestone. Galaxies form, stars ignite, planets solidify, life emerges, oxygen transforms oceans, multicellular organisms appear, the Cambrian explosion fills the seas with complexity, life moves onto land, dinosaurs dominate, mammals rise, and finally, humans emerge in the last fleeting minute. Consider January and February, when the universe is young. Galaxies swirl into shape, stars are born and die in explosions, scattering elements across space. The Milky Way itself slowly coalesces, along with countless other galaxies. These events are distant and ancient, beyond comprehension in human terms. Yet, they are foundational. Without the formation of stars and the distribution of heavy elements, Earth could not exist. Carbon, oxygen, iron, all the ingredients for life are forged in these distant stellar furnaces. March through May bring the coalescence of our solar system, the formation of Earth, and the chaotic early eons of a volatile planet. Meteors bombard the surface, volcanoes rage, and the crust stabilizes. Oceans appear. Life is poised to begin, but the stage is harsh, inhospitable, and unforgiving. You can imagine Earth as a newborn world, fragile yet full of potential, waiting for the spark that will ignite life. June and July mark the slow and patient emergence of single-celled organisms. Microbes populate the seas, quietly shaping the atmosphere. Oxygen slowly accumulates, altering conditions for future life. For you, it is a humbling thought. For half of the cosmic year, the world was inhabited only by microscopic life. Yet these organisms, in their small, unseen ways, set the stage for everything that follows. Every breath you take today owes itself to this patient work of billions of years. August and September bring the great oxygenation and multicellularity. Tiny cells cooperate, form partnerships, and evolve into more complex organisms. September sees the first soft-bodied multicellular life, the Ediacaran biota, drifting in the seas. In October, the Cambrian explosion suddenly fills oceans with diversity. Trilobites, anomalocarids, spiny worms, and armored predators. Life is no longer slow and hidden. It is vibrant, mobile, and dynamic. November witnesses the first steps onto land. Plants colonize the continents, fungi form symbiotic partnerships, and arthropods venture onto damp forest floors. Amphibians take the first tentative steps beyond water. Life begins to reshape not only the oceans but the land itself, slowly, imperceptibly, patiently. The stage is set for the dramatic expansions of December. December is a rapid crescendo. Giant insects, amphibians, and reptiles dominate. Dinosaurs rise, rule, and eventually vanish. Mammals quietly diversify in their shadow. Finally, humans emerge in the last hour, a recent arrival on a planet that has already endured billions of years of change. Every invention, every city, every story is compressed into the final minute of this cosmic year. In perspective, humans are fleeting, yet remarkably influential. This calendar, when viewed in its entirety, is staggering. The vast majority of time passes without anything we would recognize as familiar life. Humans, civilizations, and modern technology are barely perceptible in the final moments. Yet, despite our brevity, the actions we take carry weight. Our choices now will ripple forward, just as the oxygenation of the seas or the first multicellular experiments shaped everything that followed. Thinking about it this way gives a profound sense of humility. We are recent players on an ancient stage. Mountains have risen and eroded. Continents have drifted. Oceans have expanded and receded, and yet humans arrived only in the last minute. Imagine a friend asking where you were for 11 months and 59 minutes of the year you simply were not there. This realization can be disorienting but also grounding. It reminds you that life is vast, patient, and indifferent, and that we occupy only a tiny slice of cosmic history. Yet, there is also inspiration in this perspective. Humans, though recent, have the ability to reflect on the past, understand the present, and plan for the future. We can study the history of Earth and the universe, learn from it, and choose how we influence the planet in the time that we do occupy. Every invention, every act of stewardship, every insight is an echo of the long history that preceded us and a seed for the future. Consider the idea of time compressed into a year as a tool for understanding scale. It helps you grasp the immensity of evolution, the patience of the cosmos, and the fleeting nature of human existence. When life first appears in June or July, when multicellular organisms arise in September, or when humans arrive in the final minute, the calendar gives you a visceral sense of how tiny and recent our presence is. It turns abstract numbers billions of years into something you can imagine and feel. It is also a tool for reflection. What does it mean to exist in the final seconds of a cosmic year? How do you, as an individual, relate to billions of years of history? If life persisted patiently for nearly a year without humans, what responsibilities do we carry in our brief time? How do we honor the past, understand the present, and influence the future responsibly? These questions, like the universe itself, have no simple answers, but pondering them expands your awareness of your place in the cosmos. Even in this reflection, there is room for wonder. You can imagine watching the Earth in January, witnessing galaxies forming, or in August, seeing oxygen slowly accumulate in the seas. You can picture September's soft-bodied creatures, October's Cambrian explosion, and November's first amphibians exploring land. And finally, December's rush of life, dinosaurs, mammals, early humans, leading to the moment when you sit and listen now, contemplating it all. The entire year becomes a story, immersive and alive, rich with detail and meaning. Perhaps most importantly, this perspective encourages patience and humility in daily life. The universe has operated for billions of years before humans arrived. Change is often slow, incremental, and subtle. Life adapts quietly, ecosystems adjust, and species evolve over eons. By appreciating this, you can see your own challenges in a broader context. Many things that feel urgent now, minor setbacks, daily frustrations are fleeting in the grand scheme. The cosmic calendar reminds you that persistence, patience, and awareness often matter more than immediate results. As you drift further into thought, consider this. Every breath you take connects to billions of years of history. The oxygen in your lungs, the calcium in your bones, the complexity of your cells, all of it traces back to cosmic and biological events written into the calendar. You are a participant in an ongoing story, both influenced by the past and shaping the future. Finally, the cosmic calendar invites you to imagine what comes next. Humans have arrived only in the last minute. What might we achieve in the next hour, century, or millennium? How will our actions shape the Earth, the biosphere, and perhaps even the cosmos beyond? And beyond human imagination, what continues to unfold quietly, slowly, in the months and years we cannot perceive in stars, planets, and the unseen evolution of life elsewhere? In the quiet of your room, with the cosmic calendar stretching across your mind, you can appreciate both the vastness of time and the minuteness of human history. You can reflect on patience, on persistence, on impact, and on responsibility. You can imagine the entire universe as a year-long story, and your life as a single, meaningful second within it. And as you close your eyes, the question lingers. If billions of years led to your presence in these final seconds, what will your presence contribute to the story yet to be written? As December 31st nears its final minute, the stage is set for humans, our species, our ancestors, and the civilizations we will build to enter the scene. It is 11:58 p.m., and the Earth has already endured 11 months and 58 minutes of evolutionary history. Dinosaurs have risen and fallen, mammals have diversified, forests and oceans have flourished, glaciers have waxed and waned, and continents have drifted into familiar positions. The stage is vast, complex, and alive, and now humans begin their journey in the briefest cosmic sliver. At 11:58 p.m., our earliest ancestors, members of the genus Homo, appear in Africa. These humans are already upright walkers, capable of carrying objects, and equipped with growing intelligence. They hunt in small groups, forage for plants, and begin experimenting with simple tools made from stone and wood. Life is harsh, yet opportunity abounds. The innovation of tool-making, subtle at first, marks the first real divergence from mere survival. Humans are starting to shape their environment, even in small ways. By 11:58 and 10 seconds, early humans develop more sophisticated hunting strategies. They track animals, fashion sharpened spears, and coordinate group efforts. Communication becomes more complex, laying the foundations for language. These few seconds compress hundreds of thousands of years of human ingenuity and social evolution. You can imagine a small band huddled around a fire at night, sharing discoveries, teaching children to craft tools, and preparing for the challenges of the next cosmic seconds. At 11:58 and 20 seconds, humans spread across continents. Migration takes them into Asia, Europe, and eventually the Americas. Each journey is a monumental adaptation to new climates, terrains, and challenges. Ice ages arrive and retreat, shaping migration paths, influencing food sources, and forcing ingenuity. Humans learn to control fire, construct shelters, and manage resources. Even in this compressed cosmic minute, survival depends on skill, observation, and cooperation. By 11:58 and 30 seconds, agriculture begins. Humans tame plants and animals, clear fields, and irrigate rivers. Villages appear, societies develop hierarchy, trade, and collective knowledge. The shift from hunter-gatherers to farmers marks a pivotal milestone. Humans are no longer just surviving, they are actively shaping their environment to suit their needs. Crops and domesticated animals spread, increasing population density and allowing culture to flourish. At 11:58 and 40 seconds, writing emerges. Symbols scratched on clay or carved into stone allow humans to preserve knowledge across generations. This sparks the rise of civilizations: Mesopotamia, Egypt, the Indus Valley, China, and Mesoamerica. Architecture, governance, art, and religion develop. Within these seconds, humans condense thousands of years of cultural, intellectual, and technological advancement into the blink of cosmic time. The pace accelerates dramatically compared to the patient, measured changes of previous months. By 11:58 and 50 seconds, the classical era is underway. Greece, Rome, Persia, India, and China are centers of philosophy, science, mathematics, and art. Knowledge accumulates and spreads through trade, conquest, and scholarship. Libraries preserve human thought. Astronomy, medicine, and engineering flourish. In the cosmic year, these civilizations rise and fall in mere moments, yet they lay the groundwork for the modern world. At 11:59 p.m., the Industrial Revolution begins, compressed into a second or two. Steam engines, factories, mechanized transport, and urbanization reshape the planet. Coal and later oil power entire civilizations. Human activity accelerates dramatically. For the first time, humans reshape landscapes on a global scale. Cities sprawl, forests are cleared, and technologies begin to connect continents. Energy and knowledge multiply, creating the foundation for the modern era. By 11:59 and 10 seconds, modern science emerges. Electricity, telegraphs, telephones, and railways link humanity in ways unimaginable to previous generations. People begin to explore the Earth systematically, charting continents, oceans, and species. The pace of discovery intensifies. Each innovation builds on the last, and the trajectory of human history quickens in a burst of intellectual energy. By 11:59 and 20 seconds, the modern age continues. Electricity lights cities, airplanes cross the skies, and telecommunication connects the globe. Medicine reduces mortality. Civil rights and social revolutions reshape societies. Humans colonize previously inaccessible environments, from deserts to polar regions. Every second compresses centuries of innovation, struggle, and human creativity. The impact on the planet is profound, yet still only a fraction of the cosmic year. At 11:59 and 30 seconds, the 20th century surges forward. Humans send rockets into space, land on the moon, explore other planets via probes, and begin mapping the human genome. Global conflicts, technological breakthroughs, and social transformations occur almost simultaneously in the cosmic calendar. Humanity's awareness of the planet and the universe expands. Satellites orbit, data flows, and the collective knowledge of billions of people grows exponentially. By 11:59 and 40 seconds, the present day emerges. Digital technology connects billions of humans instantly. Cities dominate landscapes, scientific knowledge accelerates, and environmental challenges become global. Humanity has evolved from small bands of hunter-gatherers to a species capable of understanding, exploring, and altering the planet and beyond. These final cosmic seconds highlight both our potential and our fragility. This perspective is humbling. For 11 months and 59 minutes, the Earth existed without humans. Yet, in the final minute, we became the dominant species, shaping civilizations, altering landscapes, and exploring beyond our planet. All of recorded history, all of human innovation, and all the marvels of modern life occur in the last 60 seconds of a cosmic year. The scale is staggering, yet it also emphasizes responsibility. Our actions, though brief in cosmic terms, leave indelible marks on the planet. Even in this compressed timeline, the story of humans is one of adaptation, creativity, and persistence. We survived ice ages, migrated across continents, tamed the land, and built societies. We invented writing, mathematics, and technology. Each innovation is a bridge from the ancient Earth to the present day, a reminder of the ingenuity and resilience of our species. And yet, these final seconds also teach humility. Humans, despite all achievements, are still new arrivals in the cosmos. The universe has endured billions of years without us, and will continue long after we are gone. Extinction events, climate shifts, cosmic changes, the Earth and universe do not pause for our presence. Our brief moment demands awareness and careful stewardship. As you reflect on these final seconds, consider the scale of time. How does it feel to realize that all of human history, from the first tools to modern technology, fits into less than 1 minute of a year? How does it feel to be part of a species that arrived only at the very end, yet has the capacity to shape the planet and explore the universe? The perspective invites both awe and responsibility, wonder and contemplation. Finally, as you drift towards sleep, Imagine the cosmic calendar laid out before you, January 1st to December 31st, a full year of the universe's history, with humans arriving only in the final minute. Think of the billions of years that preceded you, the countless species that came and went, the oceans, forests, mountains, and skies that formed before your time. And then reflect. In this fleeting moment, what legacy will you and your species leave behind? How will the final seconds of the cosmic year be remembered? As the cosmic calendar draws to a close, the clock strikes the final seconds of December 31st. Humans, our species, have arrived. For almost the entirety of the year, life on Earth has unfolded without us. Stars have formed and died, galaxies have rotated and merged, continents have drifted, oceans have churned, and life has experimented in countless ways, from the simplest microbes to the most complex dinosaurs. And now, in these last fleeting moments, humans emerge to inherit a world that has been billions of years in the making. Consider the scale. If the Big Bang occurred at 12 a.m. on January 1st, and the present moment is midnight on December 31st, humans have existed for less than a minute of cosmic time. Our civilizations, inventions, and accomplishments compress into a cosmic heartbeat. From the first stone tools to space probes orbiting other planets, all of human history fits into the last 60 seconds. This perspective is both humbling and awe-inspiring. For most of the cosmic year, the universe was indifferent to us. Stars ignited and died, planets formed and cooled, Earth's oceans swelled, continents shifted, and life emerged and evolved in silence. Microbes oxygenated the seas, multicellular organisms flourished in the Cambrian, and life slowly ventured onto land. Dinosaurs rose and fell, mammals diversified, and countless species appeared and vanished, leaving fossils as whispers of their existence. All of this, billions of years of natural history, occurred before humans ever walked the Earth. Yet here we are, in the final seconds, capable of reflection, imagination, and intervention. Humans can observe the cosmic calendar, study the history of life, and plan for the future. We can understand the processes that shape the Earth and universe, and take responsibility for the consequences of our actions. The brevity of our presence is a reminder of both our fragility and our potential. Even in a fraction of cosmic time, we have the capacity to leave lasting impact. This reflection brings two profound lessons. First, patience and persistence matter. Life on Earth did not rush to create complexity. It took billions of years of gradual change, experimentation, and adaptation to reach the point where humans could exist. Every ecosystem, every species, every geological transformation built on countless prior events. Second, the power of even brief action is immense. Though we are latecomers, our decisions can influence ecosystems, climates, and even the fate of other species. A single minute, in the context of billions of years, can still shape the story of a planet. Imagine the final minute of December 31st. The earliest humans step out of African savannas, small bands foraging and hunting. Seconds later, they migrate across continents, adapt to glaciers and deserts, and experiment with agriculture. Cities rise, empires expand, inventions multiply, and knowledge accumulates. The Industrial Revolution transforms energy, technology, and society. Space exploration begins. Satellites orbit the Earth. Humanity reaches for the stars. All of this unfolds in less than 60 seconds of cosmic time. This perspective reframes our sense of history. Civilizations that feel ancient to us, Egypt, Mesopotamia, Rome, Greece, China, are cosmic infants, mere fractions of a second in the grand scheme. Every empire, every war, every discovery, every invention is a brief pulse in an immense continuum. And yet, despite their brevity, these events carry profound significance. They illustrate the extraordinary capabilities of life to adapt, create, and reflect, even within an incredibly short span. It is also a reminder of humility. The universe existed for billions of years before humans arrived, and it will continue long after us. Stars will die, galaxies will collide, and Earth may eventually be uninhabitable. Our species, despite intelligence and ingenuity, is a fleeting presence. Understanding this perspective encourages responsibility. If we wish our legacy to endure, we must act wisely in the time we occupy. The cosmic calendar also inspires wonder. Imagine observing January's galaxies, March's planetary formation, July's microbial seas, October's Cambrian oceans, November's first land life, and December's dinosaurs. And finally, the last minute brings humans the only species capable of contemplating the entire story. We are not just participants. We are observers capable of understanding the deep history of the cosmos. The brevity of our presence heightens its significance. This perspective also highlights the interconnectedness of all life. Humans are the result of billions of years of evolution. Every breath we take depends on oxygen produced by ancient photosynthetic organisms. Every molecule in our bodies traces back to stars that lived and died long before Earth existed. The soil we farm, the water we drink, and the landscapes we inhabit are products of processes that span eons. We are both a product of cosmic history and stewards of its continuation. As the final seconds of December 31st tick away, it is natural to reflect on the future. What might humans achieve in the next cosmic second, minute, or hour? How will our actions shape Earth's ecosystems, climate, and biodiversity? Will our species survive long enough to witness centuries, millennia, or even millions of years into the future? The cosmic calendar reminds us that even a short presence can carry profound consequences, both positive and negative. This reflection is not only about scale, but also about perspective. Daily worries, minor setbacks, or fleeting frustrations fade when viewed against the backdrop of billions of years. Time, patience, and persistence are far more expansive than our immediate experience. The cosmic calendar encourages humility, mindfulness, and appreciation for the vastness of life and the universe. Finally, December 31st invites curiosity and imagination. If the entire universe's history were compressed into a single year, where do we fit? What will the next cosmic minutes reveal? How might life continue to evolve on Earth or elsewhere? And perhaps most importantly, how will humans arriving so late contribute to a story that began long before us and will continue long after we are gone? These questions linger, unanswerable yet profoundly meaningful, encouraging reflection as we drift towards sleep. As you close your eyes, imagine the year-long story of the universe. January 1st's explosive birth, the slow building of galaxies, planets and oceans, the patient evolution of life, the dramatic Cambrian explosion, the conquest of land, the rise and fall of giant reptiles, the quiet diversification of mammals, and finally, the last minute in which humans emerge to shape, explore, and reflect upon it all. Every second of this cosmic year holds meaning, and in the final moments, we participate in a story billions of years in the making. Perhaps the most remarkable thought is this: though humans appear only in the final minute, we are capable of reflection, imagination, and foresight. We can understand our place in time, appreciate the scale of history, and influence the trajectory of life on Earth. The cosmic calendar reminds us that even brief existence carries potential, responsibility, and wonder. And so, as the cosmic clock strikes midnight, the year is complete. The universe continues, vast and eternal, yet we, in our brief cosmic second, have the opportunity to reflect, to learn, to care, and to leave a mark. The story does not end. It continues, and in the grand, slow, patient unfolding of time, the final moments of December 31st are ours to inhabit, imagine, and shape. The final thought lingers. If billions of years led to your presence in these fleeting seconds, what will your presence contribute to the story yet to unfold? How will the choices of our species resonate through the long arc of time? And in that reflection, as you drift towards sleep, you can imagine the universe stretching before you, vast, ancient, and full of possibility with humans, brief and remarkable at the very edge of this cosmic year.